Alright, let's go look through the rules. Normal Sudoku rules apply, so 1 to 9 in every row, every column, and every 3x3 box. Region sum line. So the sum of digits on a blue line within a particular region must be the same for all regions the line passes through. So the lines pass through different regions. And for each region, the sum of digits in that region on the blue line is the same. So like if this was like a 7, then these sum to 7. And then these would sum to 7. You could have like a 2 and a 5 here. So something like that. And then sandwich sums, which means that these little numbers outside, I hope you can see those numbers. Yeah, you can barely see them. It's almost out of the frame. But yeah, you can see them. What those clues mean are the sums of digits between 1 to 9. So if 1 was here and 9 was like there, then these digits would have to sum to 9 and would have to be 2, 3, 4, or something like that. So those are the rules. Yeah, so this is Dancing Crane by Scaly, Griffon, and GlitchHorse. Yeah, with that, let's start solving. Okay, so first thing I see is probably, well, ignoring the outside clues first, I'm a bit scared of sandwich in general. But these region sum lines here, this is one digit which sums to 3 different digits, meaning minimally it has a sum to a 6 if you have 1, 2, and 3 here. So this is at least a 6. That's basically it. That's basically all I can do. I mean, this one also means that those two are the same digit. Should I color that? I could probably color that. Yeah, okay. Well, this 35 and this 0 are also pretty interesting because 35, yeah, okay. In every row, and every column and in every box, there are digits 1 to 9, which in total sum to 45. Excluding the 1 and the 9, the digits remaining will sum to 35. And therefore, if a 35 clue exists, it must mean that every digit outside of 1 and 9 are between 1 and 9. Which is very ironic what I just said, but yeah, hopefully you get me that these have to be 1 and 9 and everything else is squished between it. So very tall sandwich. The 0 is in fact the opposite, where the 1 and 9 have to be touching each other because you can't have anything between it, otherwise there will have to be 0, which isn't possible. So actually I will remove this color first because what I want to do is color all these sandwich crusts, as they like to say. 1 and 9 must be together in this 0 over here, which actually does help because we can prove that these are not sandwich crust. If they were, then the second sandwich crust must be touching it so that there's nothing between them, and in this case there will be a lot of 1s and 9s in the same box, which does not work. So those are not sandwich, which I'll mark with pink like that. But this can be sandwich if this was also sandwich, and we can do the same here. I guess, yes. In every row, every column, in every box, there's only 1, 1, and 1, 9. So there are only 2 possible sandwich crusts in every such, such set. I can also say that these can't be, these can't be crust because you can't have nothing between it that sums to 9. So those can't be crust. And I can even go one step further to say that this isn't crust either. Because if it was, then this digit would have to be a 9, right? That's the only way to make one digit sum to 9. And that removes a 9 from both of these cells, which does not work. They have to be 1, 1, and 1, 9. So this isn't crust either. This 33 clue is what's next then. Because this is not crust. How am I gonna vocalize this? How am I gonna say this properly? I do know that these two must not be sandwich crust. And the reason why is, I guess you could say that the digit outside the sandwich, or the digits outside the sandwich, are what is excluded from the sum. So that is to say, everything else sums to 35. And if everything in a sandwich sums to 33, then the excluded digits, or the excluded digit, must sum to 35 minus 33, which is 2. So basically what I'm saying is whatever's outside the sandwich must sum to 2. It can only be done so with a single 2 itself. It can't be two 1s because that breaks the column. So this just has to be 2, and then the rest of the sandwich is part of the sandwich itself. So those are crusts. Those are not crusts. So these are 1 and 9. That then means that here, we already have 2 crusts here, so everything else is not. Also means that between the 1 and 9 has a 3 in it, so that's just 3. What else can we say? This 2 maybe? Yeah, because these two are the same digit as we've said before. So they can't... yeah, so if this is not crust, then that's not crust either. That's useful. Yeah, this can't be crust either. Because if it was crust, the only way to have, a 2 be between your sandwich is if the digit 2 was there itself. Because you can't split it into 2 1s. Meaning that the other part of the crust has to be here. This implies that this is a 2, but that's not possible because you can't have 2 more digits summed to 2. So what that means is that this is not crust. Yeah, that's not crust. So, can this be crust? No, it can't be crust either. If this was crust, then your second crust would be somewhere else out here, and therefore this digit will be in the sandwich, which fails because your sandwich can only have a total of 2 in it, and this is already more than 2. So this can't be crust either. This can be crust if it was a 9 itself, but if not, then these two will be crusts. Okay. That's somewhat useful. Actually, no, this is also pretty useful because I didn't see that before, but this sums to 3 distinct digits and this sums to 3 distinct digits. So these are also each 6, 7, 8, or 9. Doesn't really tell me much either. This could be sandwich. Okay, I can tell you that none of these are sandwich crusts. Because if this was sandwich crust, how would you make a 9 in 3 cells? The only possible way to do it is... Well, you can't use a 1 because the crust already has a 1 in it. And so the only possible way you could do it is with 2, 3, and 4, which minimally add up to 9. Or it adds up to 9, which is the minimum you can have. But there's already a 2 in the row. So that means that, you can't have 3 cells or more in your sandwich. So the other crust cannot be in those 2 cells. Those are not crust. I think that's somewhat useful. Maybe. I mean, this 3 is pretty similar to this 3 as well. Yeah, because without a 1 inside your sandwich, you can't make 3 out of 2 cells or more. So your sandwich with a 3 just has to be a 3 inside the crust. That makes sense. What else can I say? One of these is crust. But I can't really say that that's crust. Or not. Oh, well, I can say since one of these is crust, yes, one of these are crust. But whichever the crust is, it can't be a 9, right? Because, 9 is... Well, no, this could have a 9 on it, right? Yeah, you could have you could have a 9 here and then a 2, 3 there, and then this would sum to like 14, and you could have a 6, 8 here, and then that would work or something like that. So in fact, if this was crust, this could actually be 9. So I don't think that's why we're meant to look. I was pretty close though in saying this definitely can't have a 9 on it, because these would have to be greater than 9 somehow, which doesn't work. So that doesn't work. Alright, well, yeah, I was gonna say this has to be 9, which is not true. Can I do something with this? This looks really suspicious. Somewhat because I can probably tell you what parity this is, like if this is odd or even. Because what I'm saying is that this sums to 35. This over here sums to that, which means that this is 2 times of some number. In fact, it's 2 times of this number. And then this here is, you know, 2 times the sum of this. So that means that here we have 2 times something, here we have 2 times something, and so this entire section over here has to be this entire section here has to be even, right? And so because 35 here is odd, you must have another odd number here to make the total even. Okay, that doesn't really help, but I think that is somewhat useful to say that that is definitely an even number. I'm just gonna put that in. That is absolutely useless, but yeah, by that logic, this is even. How does that help though? Not entirely sure. It could still be crust. It could still be crust. Okay. Anything about geometry that I have not looked at yet? I mean, maybe it's this 10 and this 22 here. (22) must take out 4 cells, right? Can I say that this is therefore not crust? Must 22 take up 4 cells? Because if you only had 3 cells in your sandwich, the maximum you can have is 6, 7, and 8. Yeah, and because you can't have a 9 in your sandwich, so the maximum in 3 cells would be 6, 7, 8. That would add up to 21 if I did my math right. So yeah, you cannot actually have 3 cells or less. So this actually can't be crust. If this was crust, then at most you can have 3 cells in your sandwich. So it is not crust, and therefore not a 9. That's nice, because this is not 9 either. In fact, yeah, we know that these are both the same digit, because they both sum to this 3 cells. So that's not crust either. Oh, by the way, did you follow? Oh, thank you. Appreciate it. Thanks for following. One of these are, and then this one of these are, or 2 of these are. One of these must be crust, right? Because if none of these were crust, then you cannot have 2 crusts here, because they can only maximally have 2 cells in between them, which cannot sum to 22. So one of these are crust. It can't be both either, because if they were both crust, then this can't just be 22 itself. So only one of these are crust, and therefore only one of these are crust, because there are only 2 crusts in every set of 1 to 9. So what that means is that there is always a crust out here somewhere. How big could it be? Could you have 4 cells sum to 10? No, because in 4 cells you can't have a 1 in it. So 2, 3, 4, 5 minimally sums to 14. Yeah. So you can't have 3 cells sum to 10. Oh, and therefore this can't be sandwich. Yeah, if it was sandwich, then, you know, at minimum you could have, oh, you have 3 cells, right? Did I hit disconnect? Oh my god. I actually did. Oh, did I? I don't think so. I'm still live. I did disconnect though, that's why. Alright. But what I was saying is that, yeah, 3 can still be made in 3 cells. 10 can still be made in 3 cells. Which is quite unfortunate because yeah, 3 cells to make 10 is 2, 3, and 5. So this can still be sandwich under very strict conditions, where this is also sandwich. But that means that, you know, however far away you are, 1, 2, 3, 4, yeah, you can't be this far away, basically. If this was a sandwich, even if the closer one was a sandwich, you can't put 10 in 4 cells. So this is never sandwich, this is never sandwich. Alright. Where next, actually? Is it this 22 cage? This 22 clue, I don't think I've looked into enough. Because, you know, 3... It would need to be at least 4 cells large, right? You could have these two be... You could have these two be that, though. I mean, what is outside of the 22 clue? If everything else sums to 35 and the 22 is there, then outside it must sum to 13. I see. Outside must sum to 13, huh? I mean, you can do that very easily in 2 cells or 3 cells. Oh, so is this maximally 5 cells large? If this was 6 cells... Oh, it could still be... It could be anywhere, wow. Yeah, it could be anywhere. Wow, the second crust could be anywhere. Oh man. Okay, I think I see something really strange. Yeah, it's about this 3 clue, this 0 clue, this 10 clue, and this 22 clue. All mixed together for some reason. Can this ever be a crust? Well, if it was a crust, then in here, where's the second crust? Wait, no, am I doing this right? Yes. Okay. This 2 clue is also useful because how can this 2 clue be completed? It needs to be 2 crusts with exactly 1 square in the middle. It can't be 2, it has to be exactly 1. And therefore, it's either like this or like this. Now, to say that there is 1 cell here, there is 1 crust here, there must be at least 1 crust in here as well. Right, because there are 2 crusts in here, and even if this was crust, there's only 1 crust in here. And therefore what I'm saying is that the 2 crusts in these boxes, in this box, has to be here. Meaning that there can't be another crust here if this was crust. That makes this crust. Yeah, that breaks, because how is 2 now completed? There must be 1 crust here, 2 crusts here. This can only have 1 crust, that is also 1 crust as well. That breaks a 0, because now how do you make this a 0? It's not possible. So what therefore that means is that this can't be crust, I think. Which means therefore that this crust is in one of these cells. And therefore there is 1 crust in one of those cells. Can I do this? It's a little weird, but yeah. Alright, so one of those are crust. That does not inherently mean that this is crust. That does not mean this is crust, because you can always have a crust here, and like a crust here. Yeah, okay. What else does that mean then? That's so weird. Well, okay, none of these can be crust either, because you can't have, you know, well, this can be crust if that was crust. Was it? Can it? No, no, you can't. Because if this was crust and this is crust, then by this 2 clue, this can't be crust, and by by this 22 clue, this can't be crust, which means that crust would both be removed from those cells, which isn't possible. One of those are crusts. So you can't have a crust there. You can't have a crust here as well, because, you know, you can't have these two sums have a 3 in the middle. So crust is here. Which again, we note that because 3 has to be a singular digit in between 2 crusts, it's either like this or like this. Mm-hmm. I'm not exactly sure what that means though. I want to say that, okay, let's figure out this one first. We're gonna remove all the color from here. If this was crust, then because you know, crust cannot be 4 cells or larger for the 10 clue, this can't be crust and therefore crust will be there. If this was crust though, I'm gonna use purple for this one. Because this can't be crust as well, then crust is here. So those are your 2 states possible. If this was crust for 22, then this would have to be crust as well. But if this was crust, this can't be crust and the crust would be one of these cells. Although we don't know exactly which. Right, I'm not gonna do that first. No, I don't see it. I thought I saw something, but I don't. I don't see anything. This really is something, isn't it? Nope. Nope. What? Okay, this is actually really tough. I don't want to analyze each of these cells. I don't want to analyze each of these types though. I can in fact tell you that if I can in fact tell you that this is either 1 or 3. Because if this happened, then this is the middle of the cell. This is the middle and it must be 3. But if this happened, then this must be 3. But we can also say that 9 is not here because 9 can't be on this 3 cells, this 3 cell section. So this would then have to be 1 in that case. So it's either 1 or 3. Another thing I could say is that if this happened for the 2, this can't be 1 because this is a lot actually. So if this happened, this would be 9. This would be 1. But if this happened, this can't be 9 because you know this is greater than this. So this would be 1 and this would be 9. So in either case, 9 is in one of those two cells and 1 is in one of those two cells. That's a really far stretch. I don't really think that's supposed to be helpful. So yeah. Okay, is there any clue that I'm not seeing yet? This 9 clue could be anything, man. Not any of these could be any of these could be what I think it is. Alright, well, what about this 10 clue maybe? No, not really either, because well, well, maybe it's 22 then, because if this was crust, then this would have to be crust. How would you make 22 in 4 cells? I mean, there's a lot of ways, right? There really is a lot of ways to make 22 in 4 cells. I would guess in 5 cells it's, well, in 5 cells it's actually a minimum of 20, I think. Because 2, 3, 4, 5, 6 is 20. Which means to get to 22 you need to increase by 2. But that's really easy. You could increase anything by 2. It could be 2, 3, 4, 5, 8 or 2, 3, 4, 6, 7 to make your 22. Or you could increase 2 things by 1. You know. Actually not true though. If you increase 2 things by 1 it doesn't work. Or you get something that you already have. But in 5 cells 22 is fine. In 4 cells 22 is even easier to get. So yeah. I have a feeling we do not look here. If those two were crust, then that's crust, and one of these are crust. But if those two were crust, this can never be. Can this be crust? I mean, it can if it's a 1, right? In fact, yeah, there must be a crust here somewhere. It could be a 9 here though. That's the one issue I'm having. It's like definitely a 9. I mean, it's probably a 9. It could be a 9. Let's say if there was one here and there was one here, then both of these would be there, and this would be my. If that was crust, then one crust here and then one of these are crusts. I mean, one of these are 2s, right? Yeah, one of these are 2s. Okay, I feel like I am significantly missing something now. Like, I definitely cannot tell what I'm missing. Is it a clue? Ouch. Nothing. Do I look at the like, do I look at the region sunlines at this point? Maybe not though. I can never tell you there's a 1 here though. I really should have seen that. Oh my goodness, there's definitely a 1 here because these are not 9. Yes, and if it's 876, you must have a 1 here because without a 1, then you'd have at least 2, 3, 4, which makes this a 9. So that doesn't work. So this must have a 1 in it. This is not 1. This is 9. That's 1. That's 9. That's 1. That's 9. This is not 1 or 9. But that does basically nothing to help us solve actually where everything else is. It just tells me more about stuff. Oh, I can now tell you that this can't be crust then, because if it was crust, it would then have to be 9 because of the 1 here. That doesn't work, so this can't be crust. So this is crust, which means that this is also crust, meaning that this is 3. Oh my goodness. This empty cell means that these are both crust as well. Oh. Okay, it's finally unraveling. This is not a crust then. Okay. Cool. So that's 3, that's 1, that's 9. This is 2, this can't be 1, so that's 9, that's 1. These sum to 8. It can't be 3, 5, it can't be 1, 7, so it's a 2, 6. Oh my goodness. Wow, there you go, there you go. The 1 is one of those cells. Meaning that one of these are crust. And therefore nowhere else in the row is there a crust. One of these are crust, but this 9C is there, so that can't be crust either. That's crust. And because this is not crust, this must now be crust to make it so that you know, there is nothing between them. So these are not crust, that is therefore not 1. This is actually not 1 either because we know it's not crust. So this 1 goes here. Therefore, the other crust to make up this 10 would be there because it can't be here. So this is the other crust. Meaning that these are all non-crust. These are not crust either because the 2 crusts are now there. And in fact, we can actually just do that for the entire row. Now one of these are crust, which means that this can't be crust because if this was crust, then the minimum you could have is here, and these 3 clearly have to sum to more than 22. You can do the math to check that out. But I can say that that's crust. This is therefore not crust. And therefore this is crust. So this is not crust. This is crust. This is not crust. This, well, one of these are crust. We can't tell which. One of these are crust. Can't tell which either. And then like a bunch of these are crust as well. Alright. Wow, finally. This makes that a 1. This makes that a 1. This makes that a 9. And we are somewhat cooking. Yeah, this is not a. This is now a 9. This is now a 1. 9 is in one of those cells. 9 is one of those cells. 9 is one of those cells. Okay, very good. We've got most of the crust now, and therefore we'll say that these sum to 10. Maybe they do. Yeah, the only real crust we haven't figured out are the 10, the 22, and the 9. The 9 I know cannot be 1, 8. It can't be 2, 7. It could be 3, 6, or 4, 5. So that is multiple options. This sums to 9 without using 1, 8, or 2, 7. It could still be 3, 6, or 4, 5 though. So again, similar idea, does not work. Okay. What about this? Because this is 2, 3 at minimum, so this is at least a 5. Right? Yeah, there's still a lot of options though, to be fair. Oh wait, where's the 1 in this box? The 1 in this box has to be here, so that's 1, which is also sandwich. Sandwich. It is sandwich. There you go. And we don't know where the 9 is, because it could be anywhere. No clues are telling us right now, except it's 22, which is, again, not very helpful. I don't know actually. If it was a 6, it would be 2, 3. If it was a 7, this would be 2, 4. And if it was an 8, it could be, you know, 3, 4 or 2, 5. So, not entirely sure. Yeah. I think the next point of interest is this section, but I really don't want to math it out. Let's see. If this was a 5, this would be a 10. This would have to be 35 minus this would have to be 25. Which means that if you add a 3, that would be 14. It could be 6, 8, and then 3, 5, 9 or something. Wait, well. Maybe that's not possible. Maybe it can't be 5. Let's do a bit of weird math here. If this sums to 2x and this sums to 2y, then these in total sum to 2 times x plus y. And this is 35. This is therefore, these actually sum to either 38, 41, or 38, 40, or 42. Which means that x plus y is either 42 divided by 2 is 21. It's either 21, 20, or 19. So x plus y is either 19, 20, or 21. Meaning this sums to either 19, 20, or 21. Is that useful somehow? (19, 20, 21, 6, 8, 5, 6, 8. 5, 6, 8 is indeed 20. Is indeed 19. 6. Wait, so this sums to at least. This sums to at least 21, right? Or at least 19, sorry. Yes, this sums to at least 19. So what that means is that these cells sum to at least 19 plus 6 is 25. And without the 9, the maximum you can make this is 8765, which is exactly 26. So what does that mean? If this is at least 19. If this is at least 19, this is at least 25. No, I don't think we have to go about it that way. I want to say that this has to be 5, 6, 7, and 8. Yeah, yes. Okay. Oh, okay. Yeah, I think I got it. So let's run through the entire chain of logic all over again. This is 2 times x. This is 2 times y. In total, this is 2 times of x plus y. This is 35, and with this, we know this is even, but can't be 1 or 9. We know this is odd, but this can't be 1 or 9, so it's therefore 3, 5, or 7. We know therefore that the total set of digits on this line sum to, they sum to 38, 40, or 42, which means that x plus y is half of that, and it's either 19, 20, or 21. So this is either 19, 20, or 21. This is at least a 6, and this is at least 19. Therefore, this is at least 25. But the maximum digits you can put here are 6, 7, 8, 9, which sum to 5, 6, 7, 8, because there's no 9. The maximum digits you can place here sum to 26. Which means that it is not possible for this to be 21 or 23. Wait. It is not possible for this to be 21. Because then this would sum to 27, which is not possible. So this... oh my god. So this is... This is at least... this is either 20 or 21. Meaning that this can never be 7. Otherwise this would be 21. Which doesn't work. Because that would be too big. So this is not 7, is what I can say. We also know that this is 20 or 21. Without a 9, this is 25 or 26. Without a 9 must always contain 6, 7, and 8. Yeah. The issue now is trying to figure out exactly how everything works out in either case. And I want to say that these sum to at least 21, correct? And these are equal to these, which means that this is at least 21. If this is 25 or 26, and this is at least 21, then can I say this is definitely a 5? Yeah, because that's at most a 5, right? This is okay. This is 25 or 26. These are 6 different cells, 6 different digits, which sum to at least 1 plus 2 plus 3 plus 4 plus 5 plus 6, which is 21. These cells therefore are at least 21 as well, because this sums to this and this sums to this. So these digits are equal in value to the sum of these digits, meaning that this is at least 21. But this is in total 25 or 26. So if this is at least 21, then this is at most 5 in the case that this is 26. If it was 25, then this would be 4, which is not possible. Yeah. Okay, so this is a forced minimum maximum thing. This is a maximum 26. This is a minimum 21, therefore this is a maximum of 5. That is what I am trying to prove. And I believe that that is true. So I am just going to place a 5 there. This is at most a 5 and therefore must just be 5 itself. And these must be 21 because this can then only be 26. So this is 6, 7, and 8. And these sum to 21, which have to be 1, 2, 3, 4, 5, and 6. Which means that these are therefore 7 and 8. Oh, that was my argument. I think this is right. I hope this is right. That therefore means that this is 2 and 3, which means that this 3 makes this a 2. That's a 3. This means these are not 2 and 3. These are 2, 3, and 4. Yeah. Okay, okay. I think the more I try and say this, the more confusing it gets, but I'm very slowly convincing myself of this. What does 3 go in this box? These 3s see everything but that cell, so that's 3. Therefore this, oh my goodness, 3 in the corner. Therefore this can't be 1, 8, can't be 2, 7, can't be 3, 6, and it's therefore a 4, 5. That's cool. These are 6, 7, and 8, but 6 here can't be in any of those cells, so that's 6. This is 7 and 8. Yeah, that works. This is 6, 7, 8 as well. How very convenient. Okay, this is kind of a 1 on it, I'm pretty sure. Yes, because... oh, sorry, this is kind of a 6 on it. Because 6 has to be next to 2 and 1 at minimum, and that will make this a 9 already. So that doesn't work, meaning that this can be 6. Therefore 6 is one of those cells, which means that none of these are 6, and therefore this is a 6. And that means that these sum to 6, which can only be 1, 2, and 3. So that is 2 and 3. This is a 5, this is not 5, and therefore it's 4 and 6. This is therefore also a 6 because these sum to 6. This 2, 3 means that is none of those, so that's 4. This 4 sees that, so that's 5, that's 4. This 4 sees that, so that's... wait, did I do the right thing? Yes. So this is 3, this is 2. Yep, that's it, okay. This is 4 and 5. This is 7 or 8. This 2, 6 means that is not 6. Alright, we are very slowly getting there. Okay, well this 10 clue we can use again because these must sum to 10, so this is an 8. That is a 7. What are these sum to? 17 already. So these must sum to 5. And it can't be 2 cells, because 2 cells summing to 5 is either 1, 4 or 2, 3, both of which are made impossible by this 1 and 2. So it has to just be 5 itself. So that's your final crust. Those are not crust, that's crust, meaning that those are also crust. There you go, we got crust. So that's 9, that's 9, that's 9. Wait, why did I make this crust? That's not crust at all. Okay, there you go. All your sandwiches are finished. All your sandwich clues are also probably used up. Yeah, it doesn't matter what order these are in. This 6 sees that, so that's 4. That is 6. This can't be 1, 8, 2... sorry, it can't be 1, it can't be 2, 7, it can't be 4, 5, so it's therefore a 3, 6, which is resolved by that. That's 6. That's 3, the 6 sees that, so that's 2, that is 6. Nothing else. Okay. These are 7, 8, 4, 7, 8. This 4 and 7 sees that, so that's 8. Those are no longer 8. This 8 sees that, so that's 7, that is 8. In this column, this is 4 or 5. This is 4, 7, 8 as well, which means that this has to be 4, because of the 7, 8 here, so that's 4. This is 5, sorry, 5. That's 4, that's 5. This is no longer 4. Actually, this is no longer 4, that's 7. That's 4, that is 8. Very cool. These are 2 and 6, right? 6 can't be there, so that's 2. That is 6. These are 3 and 7, which we can't fix yet. Okay. These are 2 and 3. Wait, yes, 2 and 3, which we can resolve. That's 3, that's 2. These are 5 and 6, which we can resolve by this 6 here. 5 here, 6 there. These are 4, 7, 8. Nothing. Okay. 5 in this box goes here. 5 can't be there, 5 can't be there, and this can't be 5, otherwise that would be 5 as well. So 5 goes there. So this is 4, 7, or 8 as well. These are the same. This is also 4, 7, or 8. But can't be an 8, so it's therefore just 4 and 7. This column, I don't know. 5 in this box though has to be here. This is 4, 7, or 8. It can be 4. So 4 is in one of those cells. Four here makes this a 4, and 4 here makes this a 4. So can I say that this is always a 4? This is always never a 4, right? Because 4 is always in one of those cells. How can I also prove that more properly? If this is a 4, then in this box 4 can only go here. And if this was a 4, then this is just a 4. So in all cases this is never a 4. So that's 7, I think. That's 8. This 7 sees that. So that's 3, that's 7, that's 2, that's 3. So when this box 2 goes here, and this is a 4, that can no longer be 4. 7 removes from there, and 7 is removed from there. Now these can be 8 as well because of the column. So that's 4, that's 4, that's 7, that's 8, that is 7, that is 8. This 7 sees those, which means that this is now a 7. That makes this an 8, that's a 7. Oh my goodness, that's a 7. This 8 sees that, so that's 6, that is 8. Oh my god, and solved. Holy crap. Okay, yeah, when they said this puzzle was hard, yeah, this puzzle was hard. And it's not even just because of it's not even because of finding the these guys, you know. Like the sandwich crusts are actually fine. It was the sums here that I had to like really squeeze out the minimums and maximums. Yeah, but this made me feel very proud of myself. So yeah, it was an awesome puzzle, by the way. Wow.